Let us now look at machine learning, AI, and data science. Generally, these three terms or the subject is used interchangeably, but each one has its own meaning. So it's important to understand the difference as what it is all about. So this diagram will give you the connect. So artificial intelligence, if you look at it, it's not new. It's there from 1960s, 70s and all. But those days, the processing power, the memory was less. So those days itself, people, particularly in 80s and 90s, people used to call artificial intelligence. So if you are from a computer science background, whereas machine learning and to an extent data science is recent term. So ideally, it's all subset. Machine learning is an inner subset of artificial intelligence, and data science is a kind of a subset of artificial intelligence. Machine learning can be a subset of data science itself. So this diagram gives you a big picture as what is machine learning, data science, and artificial intelligence. So machine learning is basically the innermost layer, and then comes the data science, and finally the artificial intelligence. So it is better if you take an example as such and go through it. Example, if you look at the autonomous car or self-driven car, so you can relate what is machine learning and then the data science part of it. Let's look at how machine learning can be applied on the autonomous car or the self-driven car. The car should recognize the signs, road signs, whether it is stop sign or go slow sign, what is the at what speed it needs to travel, that it needs to recognize, and naturally it will use the cameras for that. And the camera feed is then it has to, the respective program need to process it and action need to be taken, and that is where the machine learning is used. So you need to give the data set. Probably it's kind of a road sign which we are aware. Suppose if it is something like a stop sign or no entry sign, different signboards, no entry sign has to be, or if it is a stop sign itself, that data should be that is called as the label data, that is fed into an appropriate algorithm. Learning, it's called the learning algorithm, and this is a supervised learning concept. So you need to train that, saying that to the learning algorithm, you need to say this is a stop sign or go slow sign. So it will recognize and generate a pattern, and that is called as the model. It's called the model because you use the maybe thousands or millions of label data which we know, and the learning algorithm then recognizes the pattern and creates a model. Once it has the model for that particular stop sign, this is a kind of a testing part, and during the production, that is when it goes on the road, when there is a there is a stop sign or something, this will be a new data in which, based on the model, it will then recognize, okay, this is related to the stop sign or this is related to the go slow, and that is how the machine learning works, and this is called the supervised learning. So the first step is the supervised learning. That is the innermost part, and that is what you need to, there are different types of machine learning, but just to understand the difference between machine learning, artificial intelligence and data science, the first step is the machine learning part. So we will, this is the first step, and once you have the learning algorithm recognizes that and knows that, and when there is a new data going to come, it generates an output, based on the learning algorithm, and it proceeds to the next step. And the next step is it has to apply the brake. As soon as the car recognizes the stops, it should start applying the brake. So this is a kind of a human activity. The car should hit the brake at the right time, not too early, too late. Plus, we should mind the different road conditions, slippery road. This issues is the control theory. So all this is all about the artificial intelligence. That is the human behavior. Human behavior to a machine is artificial intelligence. Whereas machine learning is all about have an algorithm and train the machine. Initially, you need to train the machine with a sample data set, and later point of time in the actuals, based on the sample, you have the predictable output in machine learning. Whereas the artificial intelligence is a higher level. You need to have a human behavior based on the machine learning. You need to mimic a human behavior. In this case, you need to ensure that the car or the automobile stops, it should apply the brake. So that is the artificial intelligence. The data science is a much broader spectrum. So during the test, we see sometimes car doesn't react to the stop sign. But you need to analyze why it didn't stop. Maybe the stop sign is maybe not clear. So many other things. So probably tends to, by analyzing the data set, we find out the number of fault result depending upon on the time of the day. Our car tends to miss stop sign at night. Then we see most of the training data includes only the full data light. Now we need to add a few more nighttime picks and get back to learning. So you need to, so while training using the machine learning process, add nighttime pictures as well. So this is all about data science, is all about the data as such, how it is collected, how it is integrated. So all this is part of the data science. So data science is a full, it will include all this machine learning, artificial intelligence and all. So this is a wider picture as far as data science is concerned. So it's all about how data gets managed. So the innermost layer is the machine learning part, and in the machine learning part, there could be a subset of Internet of Things as well. So when you use cameras and how cameras can be interfaced with a computer, how to get the data from the camera to the computer or to the processor, you would use certain data integration techniques, how the sensor data can be taken into the microprocessor. Those are the IoT part, and then comes the training algorithm part using the sample data, and then it needs to, after that, it's actually the production data. Till that time, it's machine learning, and then comes the artificial intelligence. You need to invoke the human behavior of the machine so that the car applies the brake. All this is all about the data science. The topmost layer is the data science, which will encompass IoT, machine learning, and artificial intelligence as well. I hope by this you have a good understanding as how they are related with each other. That is machine learning, artificial intelligence, and data science as such. Thank you. Let's now look at the difference between programming, that's computer programming, and machine learning. Computer programming is there for quite a long time, whereas machine learning you've been hearing for last maybe about 5-6 years. So let's see what is the difference at a very high level. What is the difference? Are they same or are they different? So if you look at the computer programming per se, you will have a computer. In a computer, you'll have a program. A computer is, of course, the hardware device, and you have a program, and to the program you provide in with the data, and computer acts as a interface. Of course, that's software programming has to interact with the computer OS, and it processes the data, and based on the logic which is there in the program, it generates an output. So that's the end of it. So probably you have given a kind of a looping scenario. The program could keep running again and again. It is in the loop, and if the data is going to be fed to the program, it will analyze and it can give you the output. Otherwise, yeah, for the set of the data, it can execute once or multiple times, and it can provide a results, and it's in the program will get terminated, or it could get stopped, and it comes out of further processing. So that could be the program part or the programming part. So what is really machine learning? How is that it is different? So just like any kind of a learning process, the machine should learn. So that is the difference between the, it has to learn. To learn, yeah, for that to happen, you need to provide a set of data to the computer, and to the computer in the sense there could be a program to which you provide with the data, and you train it. Maybe something like, just as an example, suppose if it's a horse or a four-legged animal or an elephant, you provide the program with multiple visuals of the horse, and classify that as, hey, this is the horse, it has four legs, this is how its face is going to look like, it has one tail. So ensure that the program understands it, and that is called the model. Model for a horse, model for an elephant. So you give the output of this program will be a model, or it could be, and again, a kind of a program which will visualize how a horse is going to look like, or how an elephant is going to look like. So it generates a kind of a model program, and once the model program is generated automatically by this program, then that model program, when it executes and you provide further data to it, data in the sense you give a image to it, horse image, then it can say this is a horse image. If it is not, it can say this is not a horse image. So because it has analyzed the image of horse and derived out the meaning of that image, so any further running of that program will identify whether a new picture is a horse or not. So basically, in case of machine learning, you make the machine to learn. To do that, yes, it has to create an appropriate model, and that model will be used subsequently to say that whether it is a horse or not. Kind of a classification in machine learning. The classification is a critical one as far as classification model is a critical one as far as the machine learning is concerned. So that's basically the difference. In case of a programming, there's a program, you feed in with the data, and based on the logic the program has, it has to act on the data and give an output. Whereas in a machine learning, it is kind of an iterative process, so it has to learn, it has to adopt, and then once it adopts to it, then any further data which is provided to the machine learning program, it can then provide you with the results, like whether it could do a classification, or it could do the extrapolation. So any other statistical functions it can perform. So that's the machine learning part when it is compared with programming. So, and furthermore, yeah, whatever I said, machine learning is a subset of artificial intelligence. So it has to automatically learn, improve from the experience. That is where after this you have the model. It produces the model with the training data, and after the training data is provided, and you have created to produce the model. So for that model program, when it is up and running, you provide with the actual data, it can produce the results. So that's about the machine learning. And so this one, whatever is the process, so data collected, and you have something like supervised learning and unsupervised learning. That is we have to go deeper into that, but otherwise the data collection and data preparation is what you have to provide with the test data and to the program. And with the test data, it has to provide with a model, and once the model program is ready, then it can evaluate with the actual data, and that is where it is called the deployment. So it can evaluate and produce the results. So that's the process in which machine learning works. Thank you. Let us now look at the types of machine learning. So if you look at machine learning, there are two parts. One is that it's all about the algorithm, how each of the algorithm works, and it's all mathematical functions, which is the best algorithm. So you need to go deep into it, and that's more of a mathematical and statistical function to understand each one of them. That is one part of it. The other part of it is that how each of the various software products, be it Python or various Python functions, how it works, or other software products like how Oracle has its machine learning, which is of course based on the database. What is the data is there in the database? So having said that, I just wanted to briefly touch upon certain concept in machine learning. It's not a full-fledged one. If you're looking for a full-fledged one all about how the algorithm works, which one is apt, then you have to suitably choose a course which provides more detailing into the machine learning algorithm from a mathematical or statistical standpoint. So this one just give you an overview, a gist of it about the types of machine learning. So if you look at it, these are the broad categories on the types of machine learning, which is supervised, unsupervised, reinforced, deep learning, deep reinforced learning. And out of this, most of them, and you'll be seeing supervised machine learning or unsupervised machine learning, or in certain cases, deep learning. So these are the first one, and then the second one, and the fourth one. First, second is most commonly used, and of course, the fourth one is also used at times. Deep learning to identify a person. Who is that person? Particularly in case of crime investigation, after you have captured the image to identify who that person is, then probably you'll be using deep learning, which is a kind of a subset of supervised learning as well. So these are the 5 different machine learning types. So supervised, and again, if you look at it, classification is again a mathematical model. Regression classification is when the data is discrete, either this or that. Regression is a kind of could be on a continuous basis. So we use that in supervised learning, and that's where even deep learning is a kind of a subset to the supervised learning classification. Listen, who is that person? Whether maybe if it's a animal, what type of animal? Whether it is four-legged, and again, four-legged animals could be like cow, dog, cat, and so on and so forth. So that's where it's classifies based on the features. So regression is more of how is the price of the house going to be based on the certain features, the location, location, or what type of location is this, whether it's a 3-bedroom or a 4-bedroom. So those are, so determining the price is based on continuous data, and that is where regression. Unsupervised, the algorithm learn pattern from unlabeled data where the correct outcome is unknown. So based on the patterns, you make judgment. So that is unsupervised learning. Supervised, you already have a data set through which you train it, and based on the training, like say for example, a cow, you can identify, maybe you give a certain image to the supervised learning of a cow and make it learn so that it can identify a similar image of a cow. So that's initially whatever you image are provided for a cow, that is a label. So algorithm that maps the input predictors to output target based on input output pair requires label data. Label data is what you have provided with the samples. So those are labeled as a particular a particular classification, whether it's a dog, cat, or even a person. Say for example, tennis player. Once a tennis player like Nadal, you provide with the various images to that machine learning algorithm, and later if there is a person who is coming out and that person image is there, and if all the features matches with the already available label data, and if that label data is Nadal, then yes, the machine learning will point out this person is Nadal. So that's the supervised learning part. And then you have the unsupervised learning, where it is based on the pattern, clustering, feature extraction, association rule, anomalies detection, because you already know the pattern and in which pattern the actual data is going to match. You say based on this pattern, this data falls in this pattern, so you identify them as well. So that is unsupervised learning. And whatever we discussed, you have a label data, input, output. All the data is provided to the learning algorithm, and then you create a model. Once you have the model with the label data, then once there is you have the model, and if there is a new data which is going to come, so since you have already built the model, it can predict the output. So the first one is you need to have a label data or a sample in which the learning algorithm will go through the label data and have its own logic so that it can identify, and the outcome is known as the model. And once you have the model and you provide with a new set of data to it, it can predict the output based on the label data. So that's the supervised learning. And unsupervised learning is more of clustering type based on predictions, group of similar features. It creates a cluster, and then if there is a new data which is coming in, it will classify to which cluster it is. Unsupervised learning could be like if an animal, whether it is a dog or a cat, or whether it's a cow. So all are four-legged, but there are various features. So because of the how its ears looks like, whether the body is it has a hairy body, then probably you classify as a dog. And if it is small size, then you say, yeah, it's cat. Its height is maybe 50 centimeter. Then yeah, it's naturally it can be a cat rather than a dog. Though there could be exceptions, but that is how it is. You based on the clustering, the unsupervised learning, you don't have something called label in unsupervised learning. That's the point. So supervised learning classification, when the output is discrete, either this or that, that is what is discrete, either this one or that one. For example, face detection, whose person is that? And then there are k nearest neighbors, decision tree, naive Bayes. So all this are under the classification, either that or this. Regression, as I said, to determine the house price, depending upon the total area, which location. So all those are parameters. So those based on those parameters, the outcome could vary. So low budget, then yeah, the 3-bedroom house, or if it's a 4-bedroom house, the price is going to differ. If it's at a particular prestigious location, the price is going to vary. It's all based on the regression. It's based on continuous data, and you have more data points as far as the regressions are concerned. So, and as I said here, classification, k nearest neighbor, outcome is based on similarity. K nearest neighbor, this is just a blue dot, and this is red, green, and if there is a, and then you have marked the boundaries of all, this again a kind of a noise, it is bound to happen. For example, yes, there could be, we said cat is about, say for example, its height is about 30 centimeters, and some dogs could be of 30 centimeters as well. So that's a kind of a noise you could always have, but otherwise the boundaries are marked. So unknown data, when after you have the k nearest neighbor algorithm, you feed with unknown data. If it falls here, yes, it's in the boundary of blue. This is just an example. So there is also naive Bayes, which is more on the probability. And again, the ideal example could be like weather predictions. If it is hot, humid, sunny, whether it is going to rain or if it is cloudy. So it's all based on the probability. That's naive Bayes. And as I said, I'm not going to get into each of the mathematical functions. Then yes, your background should be mathematics or statistics or probability. We look at only the how Oracle has this feature of machine learning and how they are generally used, whether because in Oracle, as far as it is considered, it's on the database. So based on the data available in the database, you use machine learning to derive meaningful information from them, whether it is for visualization towards data representation, or if you want to use machine learning algorithms itself, then you could do that as well with Oracle machine learning. So that's about it. That's in a nutshell and high level overview of various machine learning algorithm. Thank you. Stay tuned. Welcome to another episode. In this one, I'll be discussing about the recent trends in the information technology or computer science, which is the generative AI. Generative AI meaning the generative artificial intelligence. We have heard about ChatGPT bot from Google as well. So what is it's all about? How does it almost similar concept happens in the generative AI as well. In case of discriminative, it will able to classify this one, or even predict in the sense whether it's a dog or if it is pug. It is able to make a discriminative one. Whereas in the generative one, it needs to generate. That's what happens in ChatGPT, because there are so much of volume of data out there. Based on the information available, it needs to generate. For example, if you're going to take any programming language, it generates. ChatGPT is able to generate the program because it knows the syntax. It has learned the syntax of the programming language. It gives an output. So that is the generative AI. So if you look at it, discriminative technique, it will classify, and it will classify as a dog. Whereas in the generative techniques, you are asking just instead of a dog, you say any programming language you want. It can do a SQL program or a Java based program. It can even generate a Python program because it has got from the various sources, it has got the syntax for the programming language. So it is going to generate the programming language itself. So instead of generating a dog image, it is going to generate the respective program itself. So that is what any of the ChatGPT is going to do, and that is why it is called as the generative AI. I hope you now have a clarity how the generative AI works. I hope you found this presentation useful. Do subscribe to my channel.